Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 1 from the October-November 2023 Pure Mathematics P1 paper from Cambridge 9709. This is paper 1, variant 2. And this question is all about binomial expansion. And one of the questions, or one of the students that I teach has asked me to go through this question, and he's having some sort of confusion with binomial expansion. So I'll go in some kind of detail. So it says the coefficient of x cubed in the expansion of 3 plus 2ax to the power 5 is 6 times the coefficient of x squared in the expansion of 2 plus ax to the power of 6. And we've got to find the value of the constant a. So if we take, for example, 3 plus 2ax to the power of 5, right? This is called a binomial because it's made up of two terms, and we need to expand this. Okay, expand it. We could go about this by actually multiplying 3 plus 2ax times 3 plus 2ax times 3 plus 2x and so on. Now that's going to be very cumbersome and tiresome. So if we look at the pattern of what happens when you expand brackets, then we come up with some sort of a method that we can use to expand without having to go through this hassle of actually physically expanding every bracket. And that pattern leads us to be able to basically find each individual term. Okay. Now, all we need from this is the term in x cubed for this particular bracket. For this one, we need the term in x cubed. Okay. For this particular one, we need the term in x cubed. So I'm going to just explain how we can get each term, but that's not what you do in the exam here. You just go straight to the x cubed term. But I just want to make it clear exactly how this works. So you have 3 brackets. One is like what's called the NCR button, which will have always the highest power, the power that the bracket is raised to on the top number. And the bottom number changes according to what term we are trying to find. And then you have 2 brackets. One is for the first term in the binomial expansion, in this case it's 3, and the other one is for the next term, in this case it's 2ax. If there was a minus sign here, you'd also put the minus inside there. Right? Now, depending on which x term we're looking for, okay, there's going to be powers here and a number here which will change. So for example, if I'm looking for the term which has just a constant, there's no x term in it, then this will be power of 0, because when you raise something to power of 0, you get 1, so there will be no x term from there. And this number here must always be the number that you add to that number to give you this number here, 5. So there's going to be a 5 here. And then here I can write 5C5 or 5C0. I could write either of these 2 numbers here, it doesn't matter. It'll give you the same answer. It'll always give you the same answer if you have something like this. Either this number or that number, 5C of that number will give you the same answer. So that's actually going to give you 1. So it will be 1 times 3 to the power 5. That will be the constant, the term which has no x. If I want to find the term in the x term, then I would put this to the power of 1. That will be x to the power of 1. This will have to therefore be 4. And here I can write either 4 or 1. It doesn't make any difference. It will give me the same answer. 5C1 is 5. 5C4 is also 5. Okay. And if I wanted to find the term in x squared, I would just replace this with, I'll put this as a power of 2. And this would be 3. And this would be either 2 or 3. And again, as I said, it doesn't matter. I could put 2 or 3 here. It will give me the same answer. 5C2 and 5C3 will give me the same answer. But what we're looking here is for the coefficient of x cubed. So what I'm going to do is, I want to have a power of 3 for this bracket, because then that will give me something which will have x cubed in it. So I'll put a 3 here, and therefore I have to put a 2 here, because I have to add up to 5. And here I can put either 3 or 2. It doesn't make any difference. As I said, 5C3 and 2 gives us the same answer. So this is going to give us, and we can now work out what 5C3 is. Calculator. So we're going to have 5C3 equals 10. Even if I put 5C2, as I mentioned, it also gives me the same answer, 10. So you're going to have 10 from here times 3 squared, which is 9, times 2 cubed, which is 8, times a cubed times x cubed. So we're going to have 9 times 8, 9 times 10, 90 times 8, which is, I think that's 720, a cubed, x cubed. Okay, so therefore we can say the coefficient of x cubed is 720 a cubed. That's the coefficient. Then we have to also look at 2 plus ax to the power of 6. And we have to do a similar thing here. So 2 plus ax to the power of 6. And we want to find from this the coefficient of x squared in this case. Coefficient of x squared. Okay. So in this case, we're going to have, here we're going to have our 3 brackets, sorry. So we have here 6 on the top. You'll have 2 in here and you'll have ax in here. And we want to find the coefficient of x squared in this expansion. So there's going to have to be a 2 power here. That will give me the x squared term. Now these 2 numbers, the powers must add up to give me 6. So there's going to be 4 here. And here, again, I could put 6c4 or 6c2. It doesn't make any difference. It will give me the same answer. Now that will give me the coefficient of x squared. So that's equal to, so we take our calculator again. We do 6c2 this time. So 6c2, that gives us 15. So you're going to have 15 times 2 to the power of 4, which is 16, times a squared. Sorry, there's something missing here. Oh, that's right, 2ax. Just make sure. It's just ax. There's nothing missing. Sorry, I was confusing with the last question. That's be a squared, x squared. Okay, so we end up with 15 times 16 a squared. So 15 times 16 gives us 240. So that's going to be 240 a squared x squared. So therefore we can say the coefficient of x squared is 240 a squared. Now they've told us that these two are related to each other in that the coefficient of x cubed in this expansion is 6 times the coefficient of x squared in that expansion. So we can say that basically 720 times a cubed is equal to 6 times 240 times a squared. Okay, that's a relationship that we know that exists. So we're going to take 240 and multiply by 6. That gives us 1,440. So 720 a cubed is equal to 1,440 a squared. I think we can divide by 720 both sides. Is that right? Yeah, that gives us 2. So if you divide both sides by 720, you've got a cubed is equal to 2a squared. And what we could do here is we could say a cubed minus 2a squared equals 0. Take out a squared as common. So we have a minus 2 equals 0. So therefore a is equal to 2. Okay, so that will give us the answer. We can say a is equal to 0, but a can't be 0. Okay, because it won't be basically a, an expansion. It won't be a binomial expansion. It will just be 3. Okay, so a can't be 0. Okay, so therefore a is equal to 2. Right, so there's the answer to this question, which is question number 1 from this paper. And I hope that was clear. Student who asked especially. And other questions from this particular paper can be found in the playlist, which will appear in the top right of the screen at the end of the video. Other questions from the topic of binomial expansion of P1 of my Cambridge collection can be found in the playlist that will appear in this region of the screen at the end of the video. If you want to look at my Excel collection of binomial expansion from P2, you'll find that over here in this part of the screen. You'll see a playlist over there that you can click on, and you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.